I think I'll start right here. Hello, my name is Bernhard Klingenberg. I'm a professor of statistics at Williams College and adjunct professor at New College of Florida. And I'm the creator of web apps that I publish at the website called ArtofStat.com. And I want to present some of those web apps today to you with a focus on inference. I've given various presentations of those apps, often focusing on exploratory data analysis, or some concepts such as correlation and scatter plots and linear regression. But today in this talk, I really want to talk about inference. So welcome for that. And you can go to that website, and I will actually just go to the website myself to show you what I mean by the ArtofStat apps. Before I go there, this should be an interactive session, please. As I keep on telling my class as I was teaching on Zoom this semester, just interrupt me, put something in the chat. I try to monitor it, although I have a very small screen here on my laptop. And I hope to have some time at the end for your questions, to leave at least 5 to 10 minutes at the end. But keep on posting questions in the chat as they appear to you, or just feel free to interrupt me at any time. I'm happy for that and for any feedback. All right, so what are ArtofStat apps? And I should apologize if my internet connection gets slower. It's because I'm in Europe. And there's a soccer match, the European Championships going on at the same time, and lots of people are streaming. So I'm competing airspace with them. And I haven't quite figured out an algorithm to make statistics talks go through the web faster than soccer ones, but I'm working on it. So what are ArtofStat apps? I think the best way to show you is to go to the ArtofStat website. So I'm actually going to switch out of my PowerPoint presentation and go to that website live, ArtofStat.com. And so that means I need to share my browser. I'm going to share, there we go, my browser, and then get me range. I just simply went to ArtofStat.com, and the web apps, you can just access them by pressing this button here, the web apps button here, or down here, just click and go to web apps. And what the ArtofStat web apps are, it's a collection, a ton, 20 of them or 30 of them, that focus on a specific topic that comes up in introductory statistics. I tried to group them by sort of bigger topics like exploratory data analysis, apps, one for categorical data, 1 and 2 groups, one for quantitative data, time series, generating random numbers and stuff like that, one for exploring association and relationships, bunch of apps like these that I will not talk about today, a bunch still under development, apps about distributional features that I'll have something to say about them at the very end of today's talk, something I'm really excited about. And then what I'll talk about today is when we move into this inference chapter of inference block of introductory statistics, where we have to talk about sampling distributions, and then finally using those sampling distributions to make inference, mostly about means, difference in means, and proportions, difference in proportions. And there's some ANOVA and chi-square test apps as well. So this is what I mean by ArtofStat apps. There's an app, a specific app that's designed for specific inferential purpose. So that's what I want to focus and talk about today. Let me quickly switch back to the slides and go full screen. So 2 purposes for these apps. One is really just to help teachers illustrate concepts and then in turn understand or help students understand those concepts by exploring them interactively with an app. So that's one big goal of the apps. And the other one is really to actually just carry out statistical analysis, to either based on prepared data or on data the students or the teacher can enter and then analyze. And I will demonstrate that today. Now, how do I use the app in my teaching? It kind of depends on what course I'm teaching. We, at least at Williams, distinguish between intrastats courses for what we call consumers of statistics, those that don't really have to produce statistics, but have to just understand and ask the right questions and interpret output. We call them consumers. So for those types of classes, typically for non-science majors, history majors, English majors, I would use them as the only software solution. I don't want to teach them R. I think that's adding too much of a layer to the course, but I want to give them some tool of doing statistics by themselves with their own data. And then if I'm teaching in a more advanced class to stats or math or econ majors, as I've recently done, I use it alongside other software like R or Stata or SPSS or any other software, where I typically would present the apps first, because everything is in one place, as you will see. And then I'll ask you to replicate the output that they see on the app with R or with Stata or with other software. Now, one I think cool feature of the apps is that they're easily accessible by everyone without any barrier, because they run in the web browser. As I just demonstrated, you can just go to your preferred web browser, go to the ArtofStat.com website, and then click on the apps. Because this is a Pearson technical talk, I'm also very thrilled that they included them in the MyLab statistics course management system. I'll have some slides about that later. Now, what's the main purpose of these apps? What motivated me to program those apps? And all these apps are based on Shiny, on Shiny applications that I started programming about 6 years ago. First off, of course, to replace boring calculator output, TI output, as you see in the upper left corner, with more, visual and more interactive apps. For its, like here in this picture, for the normal distribution, where students can enter anything for the mean and standard deviation and any type of probability, lower tail, upper tail, interval, equal tail, and see the results visually and get the corresponding areas. So that's one purpose, certainly. And then the other one is to replace generic computer output. I just picked this from a class I finished teaching this semester that used Stata. When I was teaching the t-test, they get this kind of computer output, which they're often lost, right? Students, freshmen, first course in statistics, they don't quite know what to do with all these outputs and options there. To replace that with something that's more organized and more, for one thing, for instance, writes out things. So you'll see very little abbreviations there. I try to write out things, but has plots, has graphical representations of instead of just giving intervals. Has a box where you can enter your own data, or where you can explore what happens if you add an outlier, and has sliders for confidence levels and so forth. So that's the purpose of those apps. Now, I'm going to focus on inference in this talk. So any inference, as we know, starts with understanding sampling distributions. And I've seen actually many, I don't know if you had time to go to the posters presentations. That was just before my presentation today, but I checked out some of the posters there, and there are quite a few, or a couple, that actually have the same topic. How do we use Shiny or apps to teach sampling distributions? And the key to understanding sampling distributions, I think, is, of course, simulations. That's really the only way of instead of referring to convergence and distributions. No one would understand that one. So you probably show your students a version of this definition, that the sampling distribution of a statistic describes all the potential values you can get when taking a random sample of size n from a population. I do like to add that random is really important here, not only, as we learned, to avoid biases, all sorts of biases, and to get a representative sample, but also if you didn't have random samples, we wouldn't really be able to predict the sampling distributions. There really isn't a sampling distribution for non-random samples. So random is important in two ways. And so one thing I want to focus on that I think that I recently implemented in those apps is, when we say from a population, many of the apps that I see have, well, here's a uniform distribution. Here is a normal distribution. Here is a triangular distribution. So it's sort of those artificial distributions to choose and take samples from. But I think, well, with technology, we can do actually better. There's really no true population distribution that's perfectly triangular or that's perfectly uniform. Let's actually use a real population. And so that's what I want to demonstrate first. So first, in this technology talk, I will go to the sampling distribution for the sample mean app called continuous population and demonstrate that. So give me a second. I'm going to switch over to my browser. I'm already in ArtofStat in the web app, so I'm going to start from the top, and then I'll have to scroll down. And if you want, you can follow me along if you have room on your monitor to open another window. Don't close the Zoom talk, and scroll all the way down until you see sampling distributions. And just click on the second one, sampling distribution of the sample mean, and just click on the picture. And as I click on there, what I want to demonstrate, and now I have to move this a little bit around my screen. It loads up the app. There we go. And the option you see now by default is to actually select a population distribution that is a real population distribution. For instance, this one are the median depth of students from all colleges in the United States. So that's a true population. And this is how the median depth of a student from each college, this is how the distribution of median depth looks like. It has this funny shape. And this comes from the college scorecard. So that really actually captures, I think, almost all. Here I use private four-year US colleges. And so that gives you an idea about the depth. You can choose other choose other real ones. The cost of college. Oops, I keep on clicking on the first one. The earnings, I think this is 10 years after graduation. And you get all these those are real populations. Those are all the observations they are. You can actually see the values if you expand this box here. Those are from every single college that's entered in the college scorecard, and which are almost all in the United States. You can see the median earnings, for instance, 10 years after enrollment. I'm going to focus one for this talk. Making the wrong button. I'm going to focus on the one I saw, height of soccer players. That's an interesting one because I just talked about soccer. This is taken from FIFA 19, and I think one of the posters talked about the same data set, so that's kind of interesting. This is their height. Those are male soccer players. But I'm going to focus one on a large population. This is an interesting one, but I'm going to use this one. The cost of a room for rent on Airbnb in New York City. This is a huge population. Airbnb was forced to release their data, at least in 2019. And so that's how we got a hold of all the rooms posted on Airbnb that are, I had to increase it, that are under $500. So I did make an upper bound. And those are 47,660 listings. And you can see those are all the listings there. A couple of rooms actually go for free. Then there's a couple of rooms for $10. And all the way up. And you can see this is the entire population, right? These are all the rooms that were available to rent in New York City on Airbnb in 2019. And so now, right, when we illustrate sampling distribution, now sampling from a population really becomes tangible because here's my population. All I need to do is go in there, grab a certain size sample from those 47,000 listings, and compute the statistic of interest, which for me now is going to be the mean. In this app is going to be the mean. So that's exactly what I'm going to do. Is I'm going to make this a little bit smaller again. I choose a sample size. Let's stick with the 20 by default. It goes up to 100, but you can enter any number in here. And then I'm going to press in one of these buttons. For now, I'm just going to simulate drawing one sample of size 20 from that population. And you see the histogram for the room price. From that sample, you see the mean here and the standard deviation of that sample. And in the last plot here, I keep track of the sample mean with this little bar here. And I keep on, and now I don't want to spend too much time on this because you've seen this many times. I keep on simulating samples of size 20 from that real population distribution. This is not some theoretical one. This is a real population distribution. And you can actually see the sample that was generated in here. Those are the values from the sample that are generated. So those are 20 out of these 47,000 listings. And you can speed up the simulation, and then you eventually see the sampling distribution of the sampling popping up, and then you can take the slider and see what happens if you increase n and various things there. And I don't want to spend time on that one because you know what to do and what to tell to your students. And then the good thing is now let them explore, right? They can all have their laptops open, or this also runs on tablets or even on mobile phones, and let them create their samples and explore with you as you demonstrate them. So that's one feature. There are, of course, all these other ones. You can simulate from uniform distributions or even from bimodal ones and stuff like that. But I do like this feature that there are now a lot of real and interesting data sets where we have the complete data from the entire population online. This is the distances of New York City taxi rides on December 31st. How long was the taxi ride? Very skewed distributions in there for you to explore. All right, so that was one app I wanted to demonstrate. There are others. Don't forget that sometimes students have an easier time understanding discrete population distribution. So I'm very quickly, I should have done this too fast. We just looked at this one. I'm now going to the one, same thing, same title. Instead, now we have a discrete population. And I'm going to demonstrate this one. Oh, this was this one. So there is also a real data set. I looked at the entire ratings for the Amazon Fitbit wristband. And there are, I forgot, I didn't mention this here, but there are probably over 50,000 ratings on Amazon for this Fitbit wristband. So you can sort of see this is the sampling, this is the population distribution for the 1, 2, 3, 4, or 5-star rating. All right, and so you have the true population probabilities for each of the 5 discrete outcomes. And now you can do the same thing. You can select the sample size and then see what happens if you sample from this discrete distribution and compute the sample mean, the average rating in your sample of size 35. You see the sample of size 35 here. And then you can, again, explore and how the sample mean varies around the population mean. You can sort of see this visually, and you get an appreciation for the variability. And then finally, if you do enough simulations, you get an appreciation of the shape of the sampling distribution. And sampling from, well, I would call this a U-shaped population distribution. All right, so that's something that I often do in my classes now, that I use real population distributions to sample from when illustrating the central limit theorem, basically. All right, I am going to switch over and say, well, now that we understand sampling distribution, a couple of lectures later in your course, it's time to do the first inference. So I'm going to scroll down a little bit on the apps and now look at inference for a mean. That's probably one of the first examples of using sampling distributions to conduct inference by constructing a confidence interval. And by the way, I should mention this right now. You can enter your own data here if you wanted to, but for this talk, to save time, I'm going to use pre-implemented data sets. And I mentioned the Airbnb one. And so I actually took a random sample, I think of size, let's see, 50, from this huge population I showed you before. So I randomly sampled 50 rooms, and here is the dot plot of the room prices I obtained. And so first rule of statistics, make a plot of your sample, and that's right there. That's when I titled this talk, the one-stop shop of inference. This is the first thing we want to look at, right? Plot a graph of your sample. I show a dot plot and the box plot. You can, I think, also show a histogram and the box plot, and you can even you can adjust the bin sizes. It's often necessary to explore the shape a little bit more. But I think here with 50 observations, the dot plot might be appropriate. I do see an outlier here, so that's something I could address later on, or maybe not. And now, right, everything is in one place. This is what I mean by one-stop shop. You see the descriptive statistics, the sample size, the sample mean, the sample standard deviation. You see the point estimate, the standard error. You can actually not show the t-score if you don't want to be too technical first, and just say there's a margin of error and then explain what the margin of error is. But as you explain how the margin of error is computed, you can then show the t-score again. That's coming from this t-distribution with n-1 degrees of freedom. And you see right away, because the type of inference here by default is a confidence interval, you can see already the lower and upper bound of a 95% confidence interval, both in numbers and visually. And now, right, it's again, that's what I designed these apps where it's time to explore. Well, what happens if I change the confidence level? And you talk about this. Well, if I want to have 99.9% confidence, how does that look? And well, it makes the interval wider, of course. There's no.
We got 20 minutes after here.
Perfect. It's already 20 minutes after. Oh my God. And there's no such thing as 100% confidence. So that's one-stop shop of inference. You can also, you want to downplay hypothesis testing, but it's there as well. Significance test, same screen. But the cool thing is nothing actually is computed until you actually think for a hypothesis, I have to come up with a null value. So if you want to test if the mean room cost is, I don't know, around 100, then you'll get all the output for a hypothesis test. Neatly organized, everything is there. What do you want to be there? And this is what I would display on the screen when I'm teaching about the t-test first. And it depends on the audience I'm teaching to. Do I want to go into or not how exactly the p-value is computed and what the test statistic is and how the standard error comes about? Cool thing about, you can also talk about sample sizes, finding necessary sample sizes to get a specific margin of error. So, right, for this one, room cost, I don't know, maybe I want to estimate the mean room cost to within a margin of error of $50. Maybe, right, that's precise enough for me. And then again, you see there's no result yet because, well, what we need to actually compute the necessary sample size to estimate the mean to within plus or minus $50, I need to provide a guess for the population, sigma, for the population standard deviation. I'm making this up now, suppose it's 100. And then you'll get, oh, if that's the case, and if you want to be not really precise, then you only need a sample size of 16. But I think you can actually create a plot of the required sample size versus a margin of error. And it tells you, you know, what, or plots the required sample size in terms of the margin of error. All right, because I'm almost running out of time, one more for inference. That's the one next to it. I want to mention a little bit about the Bootstrap. So same thing, inference about the mean. And this is now about constructing confidence interval using the Bootstrap. And I see you have lots of questions in the chat, so I will stop right after this one. I'll have the same data set implemented in here, the Airbnb rental. So I'll go to this one here. This the same doc we saw before. And now if you want to teach more resampling-based inference, because if you remember the population distribution was actually quite skewed for room costs, and this also indicates a skewed distribution. So you can draw a bootstrap sample, and then you can sort of see which of those dots were selected once, twice, more than twice, or not. I often point to the extreme ones. So these three were selected. So in the bootstrap sample, you see those three here, but this one not. And then in this bootstrap sample, and because more to talk about the bootstrap sample, the mean is 110. The original mean was $106. And here I'm just keeping track of the bootstrap means. You do this over and over again. Students get an appreciation of what it means to take a sample with replacement from the original sample. Often it's good to show what happens if these three are not selected. So we only have one dot here. That's the only observation from these four that made it into our bootstrap sample and so forth. And so you can click on, and as I do this is a little more computationally complex, so my internet might not be the fastest, but let's see, oh, I can get 10,000 easily, and I can see an approximation of the sampling distribution of the sample mean through the bootstrap. And then I will go to the second tab here and get a confidence interval for the mean. You can select, again, the confidence level, same kind of layout for the students, and indicating the 2.5, and this is using the percentile method, and you can see the bootstrap confidence interval. For this one, we can actually compare that to the regular T interval, and no surprise here, this was a, well, sample size of 50, that's large enough. The CLT kicked in. There's almost no difference between the bootstrap confidence interval and the regular T-based confidence interval. All right, this is about inference. There are a couple of more things. If you scroll down, the same thing that I showed you for one mean, you can also do for two means. I'm just clicking on it to give you a feel. Very same layout, same ideas, graph here, descriptive statistics here, inference down here. You can do significance tests, get representations of t-distribution and visualizations of the p-value and the test statistic, what this means. And then there's another one. I'm not going to go into this for the bootstrap for two samples. So I'm going to stop there. I want to do, before I get to your question, I want to do one thing that I'm really excited about, or two things actually. Let me quickly share, go back to my PowerPoint presentation. So I showed you these two. I do use, that's a good thing, screenshots of these apps and homework exercises. Right? You can write them up, and these are nicely typed up, but that's really convenient. You can make really easy screenshots with pre-loaded data, with your own data, put this screenshot up and include this in exercises and exams. I just wrote a Canvas exam. It's really easy. Get a screenshot up and create several questions about the screenshot for your students. So those are just some examples that well, these are from the textbook, but that you can think of how to include homework assignments. The one exciting feature is that these now made it, and this is a shout out to Pearson, this made it into the MyLab statistics. So if you're using this one, you can actually assign those exercises now with the apps, and the apps run right into MyLab. You don't even have to leave MyLab for that. So that's one exciting thing. So if you use MyLab, I invite you to try this out. And then finally, the last exciting thing I want to say is my work from the last, 6 months ArtofStat is coming to the mobile phone. I finished a distributions app, and you can see the landing page here that lets you, it's kind of similar to how I implemented the distributions app on the website. But this is now, these are screenshots from an iPhone, my old iPhone, various distributions, and finding percentiles, probabilities, and also having sliders to explore distributions and to see how their shape changes. And so if you want to become, they're almost done, they're in beta version now. If you want to become a beta tester, both for Android or iOS, please just write me an email at bklingen@artofstat.com, and I'll make you a beta tester, and you'll get this on your phone, and you can try it out. And ideally, give me feedback if it's working. All right, that's it from my side with this little plug here. I see there's a lot of comments in the chat.
Yeah,
Amy, how
I'm
much
doing my
time?
best to answer.
How much time do
But
I have
Bernhard,
left?
there's one that we just have like 3 minutes left. One person has a question. If you can do a, let's see, hold on. Can you do a Z test for means?
I wouldn't recommend that. But the sample size is large. The inference is the same for T and Z tests, but no. So, well, the T test becomes a sort of C test for large samples, but no, actually no, you can't.
Okay, that's what I thought, but I wanted to make sure.
Yeah.
Okay, any other questions that I didn't get to?
Is it possible to see both the confidence interval and significance test at the same time? Well, you just have to use this drop down. They don't show on the exact same page. You have to click either confidence interval or hypothesis test, but they are in tandem. The cost to get this app they are completely free. So the ones on the website you can access all the time. They're completely free. I will have to charge something, I think 99 cents for some of the distributions app on the mobile phone, because you cannot believe how expensive it is to hire 2 programmers to program mobile apps. But the ArtofStat apps are free, accessible at any time. Yes, so there's a couple of links there. ArtofStat.com has all the apps there. I see. There's someone asked, would it be cool to provide a tab with all the necessary expressions formulated? That's something I want to do for a long time. I have something that sort of explains the math or the stats behind the inference that shows the test statistic formula. Although that will give it away, right? That will make it harder to ask those questions on quizzes and exams. I let my students use the apps on exams. So that will make it harder, but that's a good idea. That someone put in the chat there, to make another tab for the necessary expressions and formula.
Someone asked about z-tests for proportions, and I believe you do.
Yes. Oh, yes. Those are all z-tests for proportions. Yeah, they are there. Yes, definitely. Inference for 1 proportion, for 2 proportion, and the chi-square test for several proportions. Those are all available.
Would you consider adding the z-test for the mean, since a lot of people start off with that introductory topic for hypothesis testing?
Probably not.
I know why. I know the answer to the
Sure.
why, but yeah.
It would be too confusing.
Okay.
I think it would send the wrong message.
Okay.
Yeah, don't forget, because I see a couple of comments here, you can use your own data. I showed it preloaded data that comes from the textbook, but you can easily copy, I didn't show this, easily copy and paste from an Excel spreadsheet, for instance, into the box where it asks for the data. And that often works perfectly. And students like that, and students like to play around with that. Wonderful. I think I want to end the session, and thank you very much for coming. Please do explore the apps. If you see anything going wrong, just write me an email. I would love to get some feedback. If you have any ideas about other apps, let me know. I have some projects already up there on the webpage that I need to get over the summer. I would really appreciate if you have any interest in the mobile app, maybe be a beta tester and give me feedback there too.
Thank you so much.
Sure. Murray, do you want to ask a question? Go ahead, please.
Oh, yeah. Actually, you have a very big resource on the data. And in the assignment or homework, can one use those data sets? And if they are coming from some other sources, are we supposed to find the source and make a reference, or one can freely quote, use the data and produce the result for assessment
Yes.
and
No,
learning
you
perspective?
can freely do that. Yes.
Okay.
Yes, that's fine. That's totally fine. If you want, you can cite my textbook if you want to. If you want to be really strict, that's where
that should be good. Yeah, some
that's where all
citations
the
would be
assets are
helpful. Yes.
referenced. That's where the references come from.
Okay.
And some apps already have references to the data sets. I'm not quite finished. That's another to-do project where I have a little link, say, more info about the data, where I'm really precise where the data come from and what the variables mean. But the citations of data sets are in the textbook. Wonderful. If you want to talk to me, I'm going to go to Gather and just hang out there. Just look me up under Bernhard Klingenberg. I'm going to be there at least for another half hour to an hour. And I would be happy to talk to you for anything you want to know or learn about. Thank you very much for attending, and have fun at the rest of the conference.